about transactions. And as we talk about transactions, I do want to make sure that we're kind of speaking the same language, especially when it comes to what transaction means in a non-technical sense. All right. So Craig, I'm selling you a computer. Not just any computer, I'm selling you this computer. It's got all the LED lights to make you know that it's outstanding, right? So let's model this as a sequence diagram to compare what happens in the software and this. Now, Craig, I'm going to start off, I'm the first actor, and I'm going to start the transaction process by saying, hey, Craig, I'm selling that computer right there for $500. What is your response? Oh yeah, everything you see, $500. What's your response? Hardware. All right, so the first question, and this is actually a really good question, is okay, give me some specifications. All right. And I'm going to say this is absolutely state of the art. It's got that you know, the whatever we did last year, the last class period, 3090. It's got a 3090 in there, right? All right. So Brett, now with my answer, Craig asked for a back and forth, right? I said I'm selling the PC for $500. He came back in another sequence of events and asked, give me some details. Give me the specifications. Now, I'm including everybody in this. Now that I've told you, this machine's worth probably $5,000, and I'm selling it for $500. All right, so I gave you enough specifications to know it's worth it. What's the next thing that you do?
How is some of the positive and negative things you back to this piece?
All right, so a lot of the times when I'm buying things, this is my question. Okay, so why are you selling it? All right.
I mean, that's the catch.
Yeah, exactly. So, and that's really, and you've had a very polite way of saying that. Tell me the good and the bad in this. All right. More than likely, looking at it, it's probably going to be something related to the sheer noise because it sounds like a jet engine when you're trying to play. You know, so what's that? Yeah, exactly. You're never really sure. So good. All right. But now let's say I give a response that's sufficient. Look, I am hard up for cash. I don't play video games like I want. I just went out of my house. All right. So Lindsay, it falls to you. You've now been given enough information to be assured this machine is well worth the value. What's the next thing that you do in this transaction? This sequence of events. Bargain. She's gonna try to cut me down. I told her that I'm really needing the cash and that this is a great deal at a tenth the cost. And Lou's like, oh, you need the cash, do you? Well, I got 300. So that's absolutely correct. So she makes really an offer. And the bargaining process really starts with an offer. Lindsay's going to offer me $250 for it. Now, I have a lot of options that I can go from here, all right? I can do something like, I can get offended and leave. Seriously? 500 what? And leave, right? That's definitely one of my options. But more than often, when she's expecting a bargain, I'm going to come out and go, okay, what, 400, right? So Corey, you take on the lowest buy, $400. That's the best I did. What's that?
Sure.
All right, so she agrees. Okay, what else do you do? For me, it's this awkward position. Okay, I'll buy for $400. And you stare at each other. Okay, are you going to bring it or am I going to pay you? Right? The awkward situation where it's the exchange, right? The exchange happens. Now, online, we know this consideration. Now, Jared, I don't know if you remember much eBay and stuff, but I know 4 or 5 years ago you were probably doing transactions on eBay and stuff.
Craigslist.
What's that?
Craigslist.
Craigslist, absolutely. This part can be uncomfortable. Do you pay first or do you wait for the delivery of goods?
What I did in my experience, be at a public place, you bring it, I'll bring my cash, let me look at it, and if I like it, then I'll pay it.
So I love this because what he's describing is a hostage exchange. Like we're meeting at the bridge in the DMZ. I've got these people over here that walk across the middle. Absolutely. And there's this funny sort of synchronization, right? Because you don't want to pay without seeing it. And they don't want to give it to you without the cash. And there's like this really awkward thing about this exchange. But what if I told you that exact scenario, the hostage scenario that Jared is telling us, that scenario is what happens computationally as well. If we were to model what we just talked about as a sequence diagram, with the exception of bargaining, this is what happens in a regular online transaction. A transaction, by definition, is a sequence of events that is bounded, a starting point and an ending point. And that all of the resources involved, which means what you're selling, what you're buying, and the money exchanged for that, all of that stays in a very consistent state. But we're going to talk about this in great detail. The idea of acid principles, ACID. They stand for atomicity, concurrency, isolation, and durability, that I will summarize as saying all or nothing works as it should work, right? That's really the summary of all of it. So it's kind of easier than we make it. Now, the thing about it is transactions themselves should be seen as a way to control concurrency. And I'm going to give a very good, hopefully, a good example of this, all right? So let's think about some issues with transactions. If we're talking about the internet, we have to be very, very careful about the length of transactions. I'm going to give an example from the enterprise system that we all know and love, and that is LeoNet. Hey, by the way, Zachary, since you have an ear for the quality, if it ever drops in sound quality, just let me know in the chat. I'm kind of looking back to see. I'm going to figure out where I can stand to make sure that my audio quality is maintained. So just let me know about that, Zach, if you don't mind. So let's use LeoNet as our example. If you've ever come to orientation as a student, and they get all of the people in the current orientation session in the same room, and everybody's on the computers and they're registering, right? The process of registration starts when you log into LeoNet, and it ends when you hit the Enroll Now button, and it gives you the check marks. From the beginning of login to when you hit enroll is the transaction. And a lot about the state can change between that. When we have a long request, the problem is when I have an orientation and there are 20 computer science majors in there, we have a shared resource. 20 people started that process when they logged in at 11 a.m. And by the time they hit enroll, in 30 minutes later, a lot could have happened. What could a problem be from having that long of a transaction that's being involved there? What could an issue be? Y'all are going through registration right now, right? Y'all are very lucky we don't have the problems that we used to have.
I would say like collisions between people doing it at the exact same time.
Absolutely. So that's one of the classic issues. And you end up having these race conditions because we don't have it as much now. Back in the day, on the first day of registration, and you had an 8 o'clock slot, you woke up and you did 8 o'clock because it might be full by 8:01. You wanted to have all of the transactions started, and you wanted to hit enroll now on the courses you knew that would fill up immediately, because you would actually have the case where by the time you started the transaction and you finished it, you had all of these other people coming in. It was concurrently going, changing the state of the class you were hoping to enroll in by creating this race condition. You have to be careful about that. These transactions are long. They're very long transactions. When we think about something, well, I'm going to give an example of this. I'm trying to prevent myself from talking ahead. So we have to be careful with long transactions. For one thing, there's lots and lots of people coming in and using the same thing at the same time. And a lot of times we're going to consider it a problem. All right. Oh, yeah. I love talking about this topic. I get excited and I want to walk ahead, so I apologize. That's my anxiety, is I really like talking about it. So we're going to talk about this concept of a request transaction. And a request transaction is pretty interesting. This is going to be an ideal. With long transactions, they can take days, literally days to complete. A request transaction starts and ends with a single request, and we try to limit the transaction to one link. But the only problem is we can't really use that. Okay, so this is a non-viable solution for 415, but really we use it all the time in courses like the sort of industry connect courses where we can limit the length of transaction to a single request. And I'm ready to talk about my example. I want to talk about Ticketmaster. Okay, Ticketmaster is a great example of a good transaction, and I really do mean that. I think it's really great. So let's think of a good, live event. Let's see if there's anybody doing live events. We definitely want to do concerts. Harry Styles, Justin Bieber. All right, I think I'm gonna go with the Biebs. All right, let's try to get a ticket there. I'm sure he's not sold out everywhere. An upcoming event. All right, let's do Tulsa, Oklahoma. Y'all down for a road trip to Tulsa to watch Justin Bieber sing, right? At least one person. All right, good. All right, let's see some tickets. All right, one thing to notice is that the first thing it does is it allows you to understand what the resource or available pool is. It says that the blue sections have a heightened availability. I want to see just how close I can get to the beads. So I'm going to do F1. Now, F1 highlights specific seats that are available. Oddly enough, I can't tell whether or not these are rows or not. So I'm going to click this. And it's $1,500 plus fees. Now, all of those have already been taken. That's crazy. And I'm going to do next. And here's something cool that happens. Now, this process isn't just for show. What just happened when I clicked on that seat is I clicked on a valuable shared resource. From this point on, I have started my transaction. That click started a transaction. And the question is how am I going to make sure that this doesn't get bought by somebody else from the beginning, right? Does anybody see the answer to that question? It gave me a time limit. Guess what just happened? For the next 8 minutes, 7 minutes and 30 seconds, nobody can buy that Justin Bieber ticket but me. It secured my transaction in a shared resource for 8 minutes. That's kind of cool. Really, to me, it's very cool. Ticketmaster said, okay, look, the second you click on that, before you pay it, then I'm going to get there. From this point on, the transaction starts. Now, I'm going to be honest with you. I've bought tickets on Ticketmaster for the very first time, and it was ultra limited, and this stressed me out because I had not had an account yet, and I had to do sign up. I had to go through the entire process of paying for it, which I'm not going to do now. But I had to do all of that, right? By the time that timer ran out, and 8 minutes felt very, very short. But why do they limit it to just 8 minutes? So that seat is mine for 8 minutes without paying $1 for it, right? For the next 8 minutes, it's guaranteed. I think this is incredibly cool because it answers a lot of questions about transactions. If they didn't have this timer, I, as a customer, very likely get angry. What are some of the things that can go wrong?
Someone could have came in, already had an account, you might have not had an account, and got a ticket before you could.
Absolutely, and that's going to make me very upset. If my kids are looking forward to seeing Justin Bieber, and I just put in my credit card information for better $1,500, so $6,000, right, to go see Justin Bieber, and I get to the end, it says, those particular seats aren't available. Let's see. I'm going to be upset, especially if it only gives me 3 of the seats or something like that, right? I mean, why should I be penalized because somebody else has already bought from Ticketmaster? So I'm going to be very upset, right? But could I make it better? Could I just make it like an hour-long window? That once I click on the seat, it'll hold my seat for an hour? Is it too long?
What if you don't buy it and then that screws over other people?
Absolutely. At that point, I'm upsetting other people. Ticketmaster created a way to handle these transactions in a way that sort of mitigates all of those issues. I'm going to hold on so that somebody else won't buy that ticket. But I'm also going to make sure they have to buy the ticket so it'll be open and available. This is very, very common. Sort of the joke one is the San Diego Comic-Con. The number of seats that they have is so much smaller than the number of attendees that can attend it. So whenever you try, like whenever they go on sale, you're clicking refresh as quick as you can, as quick as you can, as quick as you can, in order to get a token, in order to even buy a ticket to Comic-Con in San Diego. This is a very common approach, but I also it's one of those things when I step back and I look at it, I was like, wow, what a elegant and beautiful solution, right, to handling long transactions. TJ wanted the weekend. I wonder how much the weekend tickets were. We got nothing better to do today. You know, education, whatever. We're good. I want to see what the weekend tickets cost. Totally wasting y'all's time. I'm sorry about this, but I wanted to. Wow, a lot cheaper than Justin Bieber. That's because their VIP is only up to $650. That's surprising to me. I'd much rather go see The Weeknd than Justin Bieber. All right, back to our presentation. So let's take one more look at another transaction process. This is something that I was recently looking for, and y'all are gonna think I'm crazy, but I'm very picky about pins. So Amazon has a weird way, and why is it not doing it? Do I have to log on? I checked it this morning. Okay, there it is. All right, so I'm very picky about pins. I want to have very specific pins when I write, especially in my office. And Amazon has a unique way of handling this. Now, Amazon does not reserve inventory when it's in your cart, because I'm guessing I'm not the only one that has like 50 items in your cart, just waiting for the time when you're actually going to hit pay. Maybe because of payday coming up, maybe because it's just not worth that one package. I don't know if I'm the only one that does that, but I keep a lot of stuff in my shopping cart. It does not hold this for obvious reasons, but it does do something that I think is incredibly interesting when it talks about transaction links. For Amazon, transaction links get a lot longer, because when we're really shopping on Amazon, we might be there for an hour or two, especially if we're shopping for something really big, like a hard drive. I'm shopping for a new SSD, right? And enter in there SSD 512 gigabytes, right? There's 1,000 options. And I do want to go through a couple of hundred to make sure I'm getting the right one. So I'll put something in my cart and it might be an hour, 2 hours, 3 hours before I buy that item. Amazon has these incredibly large windows for their transactions, their links for their transactions. But they do something neat, and that is that they mitigate expectations. So for this pen, which is the pen that I prefer for clickables, it has this little thing. It says, only 13 left in stock. It shares the inventory. Now, a global powerhouse like Amazon.com is telling you that you only have 13 left of these pens. But there's something interesting about the way Amazon does this. There's a reason why Amazon ties inventory in to something like pens. The keywords are order soon. In other words, if you want to guarantee this, you have to limit the length of your transaction. In a sense, it takes that situation where somebody bought that last ticket and it mitigates and goes, hey, we told you there was only one left. Whatever happened next was on me. This actually did happen to me this past Christmas. I wanted to buy the Oculus, can't remember which one it is, but Rift 2, something, I don't know, the standalone one, right? Quest 2, that's it, the Oculus Quest 2. And I had it in my shopping cart. There was one left. By the time I hit pay, I couldn't get it. Like they just had a new inventory and they had 100 or so added into the inventory. By the time I hit pay, I didn't get it. I didn't feel bad about it because I knew what was going on underneath it. From the very beginning, it said limited quality, order immediately. So that's one way Amazon handles a long length of transactions. But there's a reason why it's there. All right. So one of the things that that we answered with each one is what can and should be done when we're talking about concurrency. That was really what the whole point of it was, and I feel like you're really there understanding why we had to do it. But I do need to tell you, be very, very careful when it comes to concurrency in your systems. Lindsay immediately pointed it out, said, wait, no, you can't have something like an hour. Somebody else reserves the right to that seat. I have this saying, like the most secure computer system is one that's unplugged, right? So the scale of things like secure, the most secure system is also completely unusable. It cuts the user out completely. The biggest weak point is immediately eliminated. But also, a completely unhindered system is the most powerful system. Yes, it's vulnerable, but it's also the most powerful. All right, for those of you that play video games, you put all your money in weapons and none in armor, right? You've got a pretty powerful machine. You put all in armor and none in weapons, and you're going to have a very boring day. The same is true for concurrency. It's really easy to guarantee concurrency. You lock everything down. You want to make sure everybody gets a chance. When they click that seat, give them a month to pay for it. That way they can get it to their next paycheck. You have to be careful about those locks that you put into place. Eventually, it will keep the system from being used. All right, so let me see. So with full, one approach is full isolation. Now, isolation from acid, and maybe I should talk more about this. I'm not sure what y'all's exposure to acid has been. But isolation means that it behaves in a system, and so all of these different things are going on. It behaves the same as it would if there was nothing else going on, like there wasn't a concurrent system. That's the principle of isolation. So when we talk about isolation, what we're hoping for is that all of the transactions that exist inside of the large transactions, all the little pieces and parts, all of the events are serializable, that they happen one right after the other. That's one principle that I want you to know the definition of. This is something that matters. Now, look here. This slide doesn't matter for everybody. But those of you that have an interest in database administration, this principle can actually be built into SQL. All right. Inside of the SQL standard, there's 4 levels of how you can force isolation. You can absolutely force isolation. And they have things like serializable, repeated read, repeat committed, and repeat uncommitted. Now I'm going to do an illustration of this in just a little bit. All right, so one more case. Let's consider paying a bill. Inside of paying a bill, this is probably the most straightforward case that we consider a transaction. So I know with our new virtualization and all that stuff, usually inside of a regular classroom, I would have everyone here and I would actually hide those points and to help with animation. I want you to strongly consider what it takes to pay your light bill, your internet bill, cable access, whatever, internet access bill, cell phone bill, whatever it is. I want you to consider paying a bill. And I want you to think about, normally I would ask you to all write it down and draw out a sequence diagram. I want you to think about each individual transaction. And I'm going to ask some questions about it. So take a second and think about it. Think about the last time you paid your power bill, your light bill, whatever it is. Think about that. God, you have to pay your light bill? Do you remember that? What bill do you pay? Maybe truck. All right, truck bill, perfect. All right, that's just something you pay online or you pay. All right. So I'm gonna talk to Kyle about this because he has a note that he pays online. Now, your GM Financial, somebody like that? Wells Fargo, we'll say Wells Fargo. All right. So here's a company that's financing, we'll say Wells Fargo. Now, you only pay this bill once per month. How do you pay that bill? What are the steps that you go through? Which site?
It's kind of more like a more automated setup right now.
Oh, so it is automated.
I don't know how it's that ability to do it.
Gotcha. All right, well,
You can maybe somebody else.
okay. You have a bill that you pay, you like that, like
I pay you
insurance. Awesome. And you get online, you pay every month.
No, you're on the phone side of the book.
See, y'all are doing free work. All right. I'll use myself anything. All right. I'll use myself as an example. It's okay. All right. Oh, you pay light bills. Okay. So you're on energy? IMCO. All right. So first off, we already know like kind of how, so tell me through the processes you go to pay it online. What are the processes that you go through? Do you know the URL to the IMCO website? Okay, that's awesome, because I'm the same way. I'm energy, and I think it's energy.com, but I'm not sure. When I pay like some bills, like Lowe's account, my Lowe's account, which is pay off every month, it's not Lowe's.com. So I Google Lowe's credit card payment, and that gets into it. Same thing with IMCO. I'm guessing that it's not Dixie, I think it's Dixie Electric's cooperative, co-op.com.org, right? So it's kind of hard to remember. So the first thing Jerry does is Google the website, which I totally empathize with. What next? All right, so he says put in his account info, but I'm guessing there's a little bit of, okay, which password is this one? A little bit? Or is it a safe password? Safe password?
I started with safe passwords to deal with Google, but before that, I used to have, I had a notebook, and then I decided to take that notebook and make a Word document. I'll have a list of passwords for a site that I used to use before Google.
Also, for both cases, what he's describing is what happens when you have an account that you only access once per month. You really have no idea what that password is. You either have to use safe passwords. My point is we have an unfamiliar process. Even though it happens once per month, Jerry does not know the password. That's good security. He doesn't use the same password for everything. But he only accesses it once per month. But oddly enough, his practices, although they're good, have extended the length of the transaction. All right, so you log on, then what happens next?
Click on, pay my bill. That point, you put in your.
Good. Is it stored automatically or do you have to enter it in? Stored automatically, good. Imagine why, right? Imagine why they have to do it stored automatically.
Right, absolutely, put it in false information, you know, because it's not.
Yeah, absolutely. Reduction of errors. What's next?
Pay my bill.
Okay, now when he hits pay my bill, here's the funny thing behind it. You get an immediate confirmation, and the confirmation says, Mr. Andre, you have paid your bill on this date. Here's a number that shows it. Oddly enough, the reason why I bring this case is, I'm going to ask you this. How many days does it take to hit your bank? 3 days to hit your bank. How many days before it hits your account? Like it might be as long as a week, though, right?
Yeah, it varies with how long, usually 3 or 4 days.
Yeah.
It takes it out.
So for me, now this happened. This literally happened to me. All right. So my pay structure changed. I went from a monthly paycheck to every 2 weeks. So all of a sudden, not just like the 1st and the 15th, every 2 weeks. It's kind of crazy. Really hard to budget. So when I first did my energy bill, it kind of got lost in the new section. And I realized that it was 1 day until the cutoff day. So I get online, I'm like, okay, I'm going to pay it immediately. Got online, got in my energy, started my transaction. Okay, what was the username? Okay, I got that. What was the password? All that stuff. Took me about 10, 15 minutes, but I got it paid. The next day, they cut my electricity off. And they acted like I was going to have to pay $50 to put it back in. But let's think about the length of the transaction. The length of the transaction started all the way from when Mr. Andre put in the stuff into Google, and it finished 3 days later. 3 days later did the entire global state of the transaction change. In my case, 3 days was extremely problematic. Okay? So we have to consider these lengths of transactions very, very closely. All right. So ACID principles, they are super important. They should be held like sacrosanct, all right? And they're also very reasonable to do. We've talked about it already, all right? So really long transactions, they're absolutely necessary. And here's what I mean by necessary. Think about the power bill situation. Kyle figured it out. He did take it out automatically. Same thing for you, right? Take it out automatically. I think most of us have auto pay on a lot of our accounts. I hate it. I hate it. I like to know exactly which days are what. And I also like the flexibility. Am I the only one that has a hard month every now and then and I want to prioritize it? I want to make sure the light stays on, but I mean, the credit cards aren't going to go away. They can wait a month. I hope I'm the only one that's had that issue. I'm glad that y'all can't empathize with me on it. But sometimes I need to prioritize and put something a little bit later. Take the late fee and move on. All right? At least Kyle doesn't have to wreck the truck to get the insurance payment to pay the truck note. Because that's also one of the things, right? So it's great to do auto pay. It's great to do auto pay. But sometimes we do need. That's the shortcut is to set up auto pay. But if it weren't auto pay, how can I limit the length of that transaction? Is there a way to? Yeah, I mean, but online, could you limit the online transaction? I should have called.
Know your password.
Yeah, I mean, it's pretty much just the only possible limitation. At the end of the day, I can't change the way you come. Right? So how do we fix it? We do our best by acknowledging and addressing concurrency wherever it's possible. All right, wherever it's possible. All right, any questions about what we talked about with transactions? I was hoping that it would take about 15 minutes longer than it did, but I got fired up. And usually there would be an assignment here, but I don't know how much it's going to work. You know what? I think I am going to do it. Give me 5 more minutes, and we're going to do an in-class assignment. And the people that are virtual, y'all can do it as well, because it really is, it's a super easy assignment, and I don't want to take it away from you. And we've got the time for it. All right. So I want to show you something on Moodle that showed up. First off, outstanding work on the RWR project. There was a lot of things that I'm gonna pick on Kyle because I just sat down picking on him. We had a great Google Meet session about it where I said, you know, Kyle, you're a software engineer. Like that's just, I want to tell you, you're a software engineer. There was a lot of questions about how should it be stored? What should it look like? What should the JSON objects look like? And oddly enough, you're about to see something happen. This course is about enterprise systems. These distinct, separate components of a system and how they mix, right? How they're going to come in. Now, we're starting to look at something. This project you've created so far is a single component of a system. It's really an API, right? It's this back-end system. And now you've seen that the connection point is a request. And you started seeing Postman that the sort of body, the method body of the request is what's being transmitted, right? The next step is going to introduce an additional component, and I wouldn't dare give it to you before spring break. I want you to take spring break off and not think about it. I'm going to reduce it to 2 phases on the RWR project, and I don't want you working on it spring break. I want you taking it easy. It's not going to be the amount of time. If you want to work ahead at 383 and 411 and all that stuff, at 375, do it, but not this class. If you have that much free time, drive to the Grand Canyon. It takes a day to drive there, a day to camp, and a day to drive back. Far more important than whatever you would ever learn in this class, right? You're going to look at what you did and you're going to go, oh crap, I got to change this. I promise you that whatever you did with your JSON objects is going to break. And that's the point, okay? Is the interconnectivity between components is the largest part of the challenge. I think for the most part, the struggles came from connecting to a MongoDB. Lots of people had those issues. Look, that's exactly what happens in these systems, especially with cloud computing. Understanding getting access to error information makes it extremely challenging. It ends up making it go into your head, like I've got to figure out what's going on because I've got some random error that I don't know what it is and I can't figure it out. It ends up coming into you to kind of figure out. The database connectivity issues were number 1. Second was getting Postman to work because maybe we hadn't been exposed to Postman. But oddly enough, getting Node to work was like number 20 on the list of challenges, right? A lot of you realize there's a lot of copy and paste on those endpoints. That was awesome. Where was the most struggle at? In the connectivity, which is exactly the point of enterprise systems. So the next thing that we're going to do is we're going to create the front end part in Angular, and it's going to, you're going to have to re-examine those connection points. You're going to have to re-examine what's in there. You're probably going to end up purging your database and rewriting that little bit of Node code to make it fit the front end code that you're going to be given, right? So on Thursday, oddly enough, we're going to be going through some Angular in addition to the next thing on transactions and locks. Now you are going to have an assignment that's going to be technically open during spring break, but it's dinky. Let me show it to you. I do mean that it's dinky, like it's not a lot of work. If you go back to DB mapping in the web, which is where we covered MVC, there's a project for a 5x5 tic-tac-toe game. And I want you to divvy up this tic-tac-toe game into MVC. Now, in reality, the V part, you don't have to worry about the view, but I do want you to maintain and think about how you would split a text-based game into model and controller, how you can split the logic out. Now, I've given you an example of tic-tac-toe.java that I guess I can actually show you that. Be helpful, I guess. Oh, and it JGrassed. Now, I didn't give you the 5x5 code, but I did give you the some sort of basic code for tic-tac-toe. That way you're spending minimal time programming. Basically, we've got a method print board. That kind of sounds like, between MV and C, which one is that? Printing the board out. V, yeah, that's the view. Now has one represents some logic. And this is where a lot of the logic is. Then we have this board. Yeah, so now this stuff, where we enter things out and all that stuff, it's going to be kind of interesting. All right. Now, it should take you about 10 minutes to extend this out to 5x5, but it is actually important that you extend it to 5x5. Obviously, one of the only places that you're going to have to change is right here. It says 3x3, you're going to have to change it to 5x5. But I want you to extend it to 5x5. When I say MVC, I do mean that you should have a class called model, a class called view, possibly a class called controller. I'd be okay if it was not. I'm sorry. Yeah, a model, a view, and I'd be okay if you don't have a class called controller, if you just use your main class as that controller. But I want you to extend this out to a design pattern in MVC. I'm not picky at all about syntax or what it looks like or what it. I want to see that you can divide out a Java program and partition it out into the concerns. It's already this close, but I want you to try to make it fit that MVC design pattern. The example that I want you to use is actually from this website from the University of Texas, San Antonio. It's what we kind of covered inside of the lecture, where it's split it out to model, view, and controller. It should be easy and straightforward. I don't want you spending hours and hours on this. I don't want you spending hours and hours on this. All right, but just split it out to MVC. Are there any questions on that? I so little care about syntax that if your game doesn't work because of some sort of visibility errors or some syntax errors you can't figure out, it will not negatively affect your grade. At no point will I hit compile and run on your code. I'm going to open up the .java files and I'm going to look at your logic for how you partitioned it out. So very seriously, I will not be running it. Don't stress about, oh, there's a syntax. I don't care. All right? I really don't. I'm not going to be reading it that way. What I want to see is that you split out those sections. It's due 2 Tuesdays from now at the beginning of class. And I'll be honest with you, I only think it's like a 30 or maybe 30 minute, maybe an hour long assignment. So it's not going to be too bad.
It shows next Tuesday.
Oh, shoot, it does? Thank you for letting me know that.
When is spring break?
Next week.
That's
Right.
That's why I like to stay with these. It's more of a surprise.
Exactly.
That is so busy that you forget.
So,
All right, so that should be prepared. Thank you very much, Phil. All right, so if there's no comments in the, all right. So now one of the world's easiest assignments, all right, for 15 points. Now the people at home, I don't care how you do this. You can open up Microsoft Paint and submit a JPEG file. You can go to Draw.io and submit a PNG file, whatever it is. I want you to do something for me that I promise is going to make sense in context. I want you to create a sequence diagram. And just as a reminder, all of this stuff is too complicated. Maybe this one. All right, that's what it kind of looks like. The people and the lines that go down the actors, all right? Here's what I want you to do. I want you to model what really happened. Not like in theory or like for you particularly, all right? I have a 1981 Chevrolet El Camino. Now, for those of you that don't know about El Camino's. It is the world's greatest vehicle. Look at those beautiful things right there. All right. None of them look exactly like mine because we've all got. Oh, that one's kind of mine. All right. So it's got a cowl induction hood. It's got the original Krager rims on it. It's got Goodrich touring TAs. Good fat tires on them. All right. Just like that. I'm selling it for $1,000. Okay. Now you've seen this on social media. You see that I'm the buyer. All right. The starting point is you have read that I am selling a 1981 Chevrolet El Camino in perfect working condition for $1,000. I want you to model us a sequence diagram. What would happen if you saw that and you did want to buy that car? Right? Model it as a sequence diagram. On paper, or you can do it on Draw.io or Microsoft Paint. Any way you can do it. I want you to model out step by step the transaction, and I want you to think about all the areas. And then I want you to think about one other thing. I want you to put a little circle on all the places you feel that the transaction can be terminated. Okay? I'm not being super strict here. On the sequence diagram, on all the different timelines, draw a little circle on all the places you think that transaction should be terminated. Or could be terminated. And y'all can just email it to me, okay? Oh yeah, that's it. If it doesn't have a V8.
What does this do?
Oh, just write in class. Just in class, yeah. And just email it to me when you're done. Or if you're in class, just hand it to me.
You see you're selling it on a certain website or just?
No, it doesn't matter. Just assume you saw it on Facebook or something. Okay. Great question. Assume there's a wrong way. Assume I'm grading it critically. But remember, it's a personal process. Yeah, we do it very, very similar. It's very important. Just look at that car. It's beautiful. You know you want it. Mine's navy blue. Oh no, Tia, you're right. It's better with it's definitely better with a V8. They do sell it with a V6, but that's not what you want. But mine is an SS and it does have the appropriate V8. I'm horrible. I forget the terminology for the mounts, for the engine mounts on Chevys. But it's a smaller one, which makes it a challenge for the big V8. So show a sequence diagram that if I'm selling this car right here, the 1980 El Camino for $1,000, for you personally, draw out a sequence diagram for the transaction that would take place. In addition to that, I want to give you a little bit of an extra challenge. Draw a little circle on the timelines in all the places that you think it would be appropriate to terminate a transaction. And the little circles are what the next lecture is going to be about. So try to put those little circles there. When should the termination be able to just stop? And you can't just put circles everywhere because there's a couple of places where it's totally not okay, AKA the hostage situation that Jared was talking about. My goodness, I couldn't remember what the term for the engine that had a smaller block, and it's like, it's a small block. So I'm sorry. The small block 350 V8. Had all the terms right there. Yeah, Mighty Mouse, absolutely. Yeah, definitely, TJ, you can draw it and take a picture. Any way that you can get it to me. I'm not picky at all. So the no, I think you're right, Susie. I think it is mine. Whenever you get that turned in, that'll be in, but I do want you to circle all the time, every place that you think that can terminate, because that's actually the point of this sheet. You go back and forth, you haggle, you deliver the car. You have to think about what it starts from. I already told you that. What ends it? But inside of it, I want you to circle all the places that it can terminate, that it should be able to terminate. That's very important. When you're done with that, you can turn it in, and we're done for the day. But I definitely would have had to check what you're doing, just to make sure that it's right. So, just here, circle. Here. And make these directions, which is one way. So remember the vehicle history, this is the person buying it. Going to here, then response back. That makes sense. Yep, that's it. Figure it out. That's it. I see, open that up whenever you turn it in, that's all we're doing, so. You're good.
I guess I can stop here.